Hello everyone, this is lesson 13, average rate of change. Okay, so what is the speed? Speed is how much the object moving fast, right? Quickly, so think, move quickly. Okay, or its units in America, US, so we are using miles per hour, right? For the car, miles per hour. We denote this way, right? So miles per hour. Okay, so I just talked miles per hour. Can we talk about the kilometers per hour instead? Yes, right? And feet per minute? Yes. Meter per seconds? Yes, right? Yes, we can use that, right? So everything distance over time, right? So distance over time. Okay, so back to miles per hour. Could we use just miles to measure speed? Like I am going to 35 miles. What do you think? This is for distance, right? Only distance. So when we talk about the speed, must be has per the time, right? Over time. So we just talk. What is the difference between saying I'm going 35 miles and I'm going 35 miles per hour? So this one talk about the speed. Also, we said the rate, right? And I'm going 35 miles means just distance. Distance. I have this one, so I'm not gonna write down here. So they say that we both distance and time, so that is the speed, right? Okay, now we have instantaneous speed. So let's talk about this one. If you look at your speed, hold on one second. So speedometer, and it says 27 miles per hour. Does that mean you are always going 27 miles per hour? No, right? So at the moment, speedometer say that 27 miles, right? At the moment, right? At the moment. Is it 27 miles per hour for the next 10 minutes? 27 miles per hour for the previous 5 minutes. Yeah. When are you going to 27 miles per hour, right? At the moment. So, yeah. So, what is the speedometer telling you? So what is that? At the moment, they telling us 27 miles per hour, right? Okay. Now, so instantaneous speed means exact time. So at the moment, right? How about average speed? Now we have which is faster, 60 miles per hour or 45 miles per hour, right? We know 60 miles per hour is faster, right? This is more faster. Why? 60 is bigger than 45, right? Yes. Okay, now we have which faster, 60 miles in 2 hours? 40 miles in 1 hour. Let's calculate 60 miles. Let's denote miles like this in 2 hours because we know that miles per hour, right? Okay, if we calculate this one, we get 30 miles per 1 hour, right? Which is 30 miles per hour. We can denote it this way, right? 45 miles in 1 hour, that means 45 miles per hour, right? Means 45 miles per hour. Okay, so we have 45 miles per hour, right? How about 20 miles in 1/2 hour? So 20 miles per in 1 hour. Okay, so if we have a fraction divided by another fraction, we can make a multiplication and the reciprocal of a second fraction, right? 2 over 1. So that will be 40. Yeah. So it's 40 miles in 1 hour, right? Which is 40 miles per hour. Okay. Then we can see that 40 miles per hour is more faster. Most fast. More faster. Which one is better sounds? More faster. Right? Okay. Now, does that mean you are always going 30 miles per hour during the entire 2 hours? No, it can be go to 40 miles, it can be go to 45 miles, it can be go to 20 miles, right? So, no. 3, 4, 5. 30, 45, 40, 42, 60, and so on, right? Okay, so what is this 30 miles per hour telling you? It's average, right? So this is on average. So your speed was 30 miles per hour, right? Okay, so we have two kinds. The speed, which is rate. So speedometer's speed is instantaneous speed. And then we just calculate 60 miles in 2 hours. That is a 30 miles per hour is average speed. So instantaneous speed and average speed. Make sense? Okay, now we have a rate of change. So it's average rate of change. So rate is the same as speed. In that case, all right? Okay, now The Carlos lives in El Cerrito and attends San Francisco State. All right, so let me read this one. The El Cerrito to San Rafael, it took Carlos 0.4 hours and 14 miles, right? So from here to here. And then 25.5 miles from El Cerrito to the Golden Gate Bridge. So here to here. And then it took 36 minutes, which is 0.6 hours. Yeah. Now 33.9 miles from El Cerrito to the San Francisco State along this route. And it takes 57 minutes and 0.95 hours. Okay. All right. Now, Carlos' average speed between El Cerrito and San Rafael was 40 miles per 0.4 hours, right? If we calculate, that would be 35 miles per hour. Okay, now we need to calculate average speed between San Rafael and Golden Gate Bridge. Yeah. All right. So we have, let me read. San Rafael, the distance from San Rafael to Golden Gate Bridge, there will be, look, 25.5 miles, right? Okay, now we have El Cerrito, which is 14 miles until from El Cerrito to San Rafael, right? So you guys okay? So we subtract from, is it better with the map? Here to, subtract from here to here, right? Then we can find from San Rafael to the Golden Gate, right? All right, so let's calculate. 25.5. minus 14. Okay, 25.5. And then 0.6 hours minus 0.4, right? 0.6 minus 0.4. Okay, so that will be, if we calculate, we have 57.5 miles per hour, right? So 57.5 miles per hour. Okay. All right. So let's find out Carlos' average speed between Golden Gate Bridge and SFSU. So this one minus that over the time, right? So let's do this. So 33.9 minus 25.5. And the time is 0.95 minus 0.6. If we calculate the numerator, we get 8.4. The denominator, 0.35. It's miles per hour. So if we calculate, this is 24 miles per hour. Okay. Okay, now we have terminology. Average speed is example of average rate of change. So speed is one of average rate of change. And what is this? This is speed tells us how distance change when time change. Yeah, that is average rate of change. Okay, now from previous example, we can derive the formula, which is average rate of change. So we have the function notation. So what was the slope before, right? So slope was, let me write down slope first. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1 for the straight line, right? So here, if we have order pair, we read the first coordinate as x, second coordinate as y, right? Okay, then let's read the first one b, and then second one is y, right? So f of b. And then we have another order pair here. Let me make this is x sub 1, this is y sub 1. Let me make this one x sub 2, y sub 2, right? Then can you see that f of b, which is y sub 2, minus f of a, which is y sub 1, over x sub 2 minus x sub 1, right? So b minus a is the same. Okay, so this is what we did earlier. Distance over time. Okay, let's do this one. Total cost. Suppose the total cost in dollars from production of X printers is given by, okay, now C of X equal to this. Find average rate of change, total cost when production changes. Okay, from 100 to 300 printers. So let's say, right? Okay, 100 to 300, that means this is X sub 1, Y sub 1, right? Okay, I'm sorry. this is X sub 1, this is X sub 2, right? Okay, how do you find Y, right? We substitute X value into the function to get the Y value, right? Which is f of b. Okay, let me denote this way because we are using this formula. So let's denote this is A, this is B. Yeah. Okay, now our job is find f of A, f of B, right? So in that case, it's C of A, C of B. Yes? All right, so C of A, which is C of 100, which is 0.0001, and substitute 100 to the third power plus 0.005 100 squared plus 2800 plus 3000. Okay, if we calculate this one, we get 5,920. Okay, how about C of B, which is C of 300? So there will be, let me copy this one. Copy. And then I want to change 300. So 300, 300, 300. If we calculate this one, we get 14,550. Okay, so let's calculate. So we want to know average rate of change. Let's denote rate of change. So there will be C of B minus C of A over B minus A. Okay, C of B, which is 14,550 minus C of A, which is 5,920 over B, which is 300 minus 100, right? So this one we get 8,600 over 200. So we get $43 per printer, right? Okay. So second part, we have same A and B. C of A, which is C of 300. We have that here, 14,550. And then C of B, which is 600, right? So C over 600. Okay, let me copy this one. So we have 600. So we get 600 is 43,200. So average rate of change is C of B minus C of A over B minus A. So we have 43,200 minus C of A, 14,550 over 600 minus 300, right? So we have 28,650 over 3, which is the money, $95.50 per printer, right? Okay, so C part interpret the result from part A and B. So let me do here. On average, it cost for the first one, it cost $43 per printer, right? It cost $43 to make each additional printer. And also for the second part is $95.50. Yeah. It's okay. All right. Let's do. Oh, we have two more. Okay, so let's read the graph. This chart shows the population, right? Okay, so find average rate of change in percent. This is a percent. Everything is percent of US population that was a foreign born from 1930 to 1970. Okay. 19, it's hard to say, right? So let me make it bigger. 1930 to 1970. Yeah. This is X values, right? And this is Y values. Yeah. Okay, so there will be AB. Okay, so let's find out average rate of change. So let's denote f of b minus f of a over b minus a. So 1970 minus 1930. And let's take a look. 1970, which is 4.7, minus 1930, which is 11.6. Let's calculate. So numerator has negative 6.9. Denominator has 40. Okay, then the final answer is negative 0.1725. This is a percent. Yeah. So this is a percent per year. This is not decimal. Okay, so this is a percent. Okay, second part, same process. This is A, this is B. So we have f of 2010 minus f of 1970 over 2010 minus 1970. Okay, let's read 2010, 2010, 12.4. It's a percent, right? So 20.4. 1970 we have earlier. 4.7, yeah? 4.7 over the denominator has a 40. So if we calculate this is 0.92, 1925% per year. Okay, so explain why the sign of your answer for A and B is different. So A, we have a negative, means it's decreasing, right? And for A, this is a C. For A, Then second part, we get the positive, means it's increasing, right? Excuse me. About percent, right? Let me denote percent per year. Percent per year. How about that? Yeah. Okay. Let's do last problem. So we have this one. So quantity demand. So we have the function. P is the price of product. So what is average rate of change? The price increase from 1 to 25. So this is A, this is B, right? Okay, let's do it. So first one, average rate of change. So we have F of B, or D of D of B minus D of A over B minus A. So B, which is 257 minus 1. Oh, we have to figure it out, right? So D of A1, which is 1,000 over square root of 1 minus 1. So square root of 1 is 1, right? So it's 999, right? So 999. How about D of 25,000 over square root of 25 minus 1. So it's 5, right? So 5 divided by that, 200? Then, yeah, 1. So we have a, why I'm calculating 199. Yeah. Okay, so 999 minus 190. Yeah. So there will be negative 33.33 the units uh, items product per price money, right? Dollars. How about that? Okay, second part, same process from A to B, 25 to 50. So B, so we have D of B minus D of A over 25 to 50, right? So 50 minus 25. So we have D over 50. We get 1,000 over square root of 50 minus 1. Then if we calculate this, 140.42, 140.42 minus let me do one more. So D of B, which is D of 50 minus D of 25 over 25, right? Equal to D of 25, we have 199 over 25. Then we get negative 2.34 product per dollar. Okay. C. plot the dot point, I mean, plot the point. So we see that 1 and 999 and 25 and 199 and 50 and let me see 140.2.42. Okay, let's plot. Let me see. 1 and 999 over here and 25 and 199. It's about here and 50 and 140.42. It's over here, right? Okay. Draw secant. Oh, they said the secant. It's a straight line. Okay, draw secant between points 1 and d over 1, 25. Okay, so let me draw here 1 and here 1 and d over 1, 25. So this is the line. So we call this is a secant line. Okay, make a straight line from the 2 points. Okay, now the last one, oh, I omitted this one. What is slope of this secant? Slope is the same as average rate of change, right? So that is the slope. This is also slope, right? Yeah. Okay, now the last one, draw secant between 25 and d over 25 and 50, right? So let me draw here. This one. The orange color, can you see? All right. So that's the secant line. Then they said that what is the slope of this secant, right? So this one is the same as the slope, right? All right. So we are done. So do you have a question? Okay. Thank you for watching. Bye.